So I want to show you now how to do this practice problem. We could just throw it down on a piece of paper and do our best to solve it, but that is not the way we do things here in physics. In physics, we are very specific on how we extract the data from a problem, how we set up the formula for the problem, and then how we solve it. This allows you to solve a problem without really needing to check and see if you're correct. Inside the problem itself, you can see that you are correct. So we start off by writing down the word givens. We do this nice and neatly. As you get better at this, you could do whatever you need to relax a little bit. That's fine. But we start off and we do it nice and neat. What are the givens of this problem? And we want to label them. Well, 1.36 kilometers. What is that? That's our distance, or our displacement. So we would just call this D equals 1.36 kilometers. However, the units are terrible for us. We can't use these units. We have to convert them to meters. How do we convert something like that to meters? Well, if you remember in the earlier lecture, we talked about the multiplication by 1. We do not want to change the distance. We simply want to change the units. So if I put kilometers on the bottom and meters on the top, how do I turn this into 1? Well, it turns out there are 1,000 meters in 1 kilometer. So running this through, I will have my answer that way. Then I have my time. Time equals 12 minutes. And again, we need to do something to turn that into seconds. What do you suppose we multiply by? The correct answer when I ask that is you multiply by 1. And then I could be more specific and say what form of 1. And in this case, minute needs to go on the bottom to cancel. And seconds goes on the top. So the minutes will cancel. And all you have to do is put the correct numbers in to make this 1. How many seconds in 1 minute? We know there's 60 seconds in 1 minute. Now we can take out the calculator. We could do some quick calculation and say 1.36 times 1,000 equals 1,360 meters. We can then say 12 times 60 equals 720 seconds. Every time we write a number down, we must write what that number means. And that is how units come along. You have to have units after every number. Otherwise, your number has no meaning whatsoever. So in physics, we are rigorous about this. But I want to show you there's a whole other reason for being rigorous about the units. And it's a very important reason. After we have our givens, we also put down what it is we seek. We're looking for the velocity. So notice we have these 3 variables right over each other, nice and neat. And if you need to, you could look in your reference table and try to find the formula. And in this case, the formula is pretty straightforward, but let's just take a look at our reference tables anyway. You see the physics reference tables. You see the list of physical constants here on the top. A variety of very important concepts here. We have all the equations for electricity, all the equations for waves in modern physics, and then we get to the equations for mechanics. Here's the equations for mechanics. And right at the top you have V equals d over t. That is in fact the formula we're going to be using. And you can see this is average velocity. Well, that's what we're going to be calculating. So V equals d over t. Do we need to rearrange that? If you need to rearrange that, you never, ever, and I repeat never, put numbers in and then rearrange it. You rearrange it algebraically first, foremost, and you do it right here. Whatever that final equation form is, goes in the next line. Substitution and solution. Substitution and solution. So you're going to take the final form of the equation, you're going to write it right at the top here. Now we're solving for v, so we don't really have to do anything to the equation at all. But we rewrite it there. This avoids confusion. We don't want to ask, is this problem correct? We simply want to solve it correctly. So, now, D. D, substitute right in, 1360 meters. The units are vital here. Time, 720 seconds. Why are the units so vital? Look at what the units come out to be. Meters per second. Is that, in fact, the unit we need for velocity? It is. What if the units say we got seconds per meter, or meter seconds? Did we solve it correct? Well, are those the units for velocity? Well, seconds per meter, or meter seconds, are not the units for velocity. So you would know you had messed up the algebra here. If you do it this way, the problems check themselves to a very large extent. The only thing you have to be careful of is entering it into the calculator correctly, which, well, pay attention as you do it. 1360. Is that the number? Yes, it is. What's the operation divided by? 720 equals. Well, this is a bigger number than this. Do we know this is going to be larger than 1? Yes, we do. The answer? 1.8 repeating. Now the question is, how many significant figures do we have here? Well, what was the original problem? We have 3 significant figures here, 2 significant figures here. How many significant figures are we justified in? Well, the least number of significant figures in the problem. So we're justified for 2 significant figures, but the rule is you can do 1 extra figure as long as you keep in mind that that is only somewhat correct. But it gives you an idea of where you're going. So we would answer 1.89 meters per second. And understanding this number, we know that this number here is vague. It's uncertain. Well, what if we were to put another number following it? That would simply be crazy. So we never do that. We carefully watch how many significant figures we have on the input of the problem. And on this one we have 2, meaning we're allowed 2, and 1 more as long as we know that this one is uncertain. But then it means clearly any other number after an uncertain number is just nuts. So be careful about that. So 1.89 meters per second would be the velocity in this problem. Again, in the givens, you sort it all out so you have the units you need. You make sure your variables are stacked neatly over each other. You use them to figure out which formula you're going to use, and we have plenty of formulas to choose from. You only include the things that you need, and then you substitute and solve. You rewrite the entire formula, you substitute the number with units into it, you first look at the units, make an assessment. Is that what you're looking for, meters per second? Well, it is. There is your answer. And that is a nice, tidy answer. Would it be ever more correct to say, oh, the answer is 1.88888888? No, no. Any number after that, you are suggesting that you do not know physics. You don't know the meaning of numbers. You don't know the lack of specificity in your input. We only measured this poorly. 12 minutes? We didn't even say 12.0 minutes. Certainly not 12.00 minutes. So you cannot write an endless barrage of numbers for your answer. You can write what you are justified in writing. Remember, physics is about knowing how precise your measurements are. That's a big part of it. So that's also then giving you an idea of how precise your answer can possibly be. Thanks for watching.